This video begins Chapter 8, Estimating with Confidence, and Section 8.1, Confidence Intervals, the Basics. So before we begin, we have to talk about a point estimator. So the definition for a point estimator is a statistic that provides an estimate of a population parameter. Ideally, a point estimate is our best guess at the value of the unknown parameter. So whenever you are talking about point estimators, it's going to depend on the type of parameter that you have. So you might have the population mean, and if you have the population mean, then your point estimator would be the sample mean. If you had a population proportion, your point estimator would be a sample proportion. And if you had the population variance, then your point estimator would be sample variance. And so you are going to choose your point estimator based on the type of parameter that you are trying to find out. So our first example, we're going to be determining the point estimator you would use and then calculating the value of the point estimate. So for A, it says quality control inspectors want to estimate the mean lifetime mu of AA batteries produced in an hour at a factory. They select a random sample of 30 batteries during each hour of production and then drain them under conditions that mimic normal use. Here are the lifetimes and hours of the batteries from one such sample. And so what we need to do is determine what type of point estimator we want to use. Now, because we know that we have the mean for a particular population, then what we are going to do is we are going to let this sample that we have here represent that entire population of AA batteries. And so the point estimator that we would be using for part A would be sample mean. And we know that sample mean is X bar. And so we need to calculate X bar for the sample that we have so that we can determine what we think would be a close guess for our population mean. And so the fastest way to do this is to do this on the calculator. And I've already kind of done part of the hard work for you. To do this on the calculator, you of course would go to Stat, you would go to Edit, and you would put all of your information into L1. And so I've already gone through and put all of the lifetimes in hours in our calculator. So we can just go from there. So once L1 is all worked out, you would go back to Stat, you would go to Calc, and you would go to 1 var stats, and you would be able to find X bar there. And so X bar is 16.68571429, and so we will estimate it to be about 16.7. So 16.7 hours. For B, it says what proportion P of U.S. high school students smoke. The 2007 Youth Risk Behavioral Survey questioned a random sample of 14,041 students in grades 9 to 12. Of these, 2,808 said they had smoked cigarettes at least one day in the past month. So for this one, you know that you are dealing with a proportion. And so if we go back and we're looking at population proportion, our point estimator would be a sample proportion. So we're going to find a sample proportion, which we know is P hat. Actually, let me write this so you've got this in your notes too. So we're doing a sample proportion, which we know is P hat. And so if you think back on when we talked about sample proportions and P hats, P hat would be equal to the number of successes over the number that we are looking at. And so our number of successes in this case is kind of strange, but 2,808 would be our number of successes because a success would be having smoked a cigarette at least one day in the past month. Our total number that we're looking at is the 14,041 students that were surveyed, and so our P hat would be 2,808 over 14,041. Whenever you work out all the math, that gives you 0.2. C says the quality control inspectors in Part A want to investigate the variability in battery lifetimes by estimating the population variance, sigma squared. And so because we are looking at the population variance, we would be using a sample variance as our point estimator. So we're going to use sample variance for this. And remember that sample variance would be your standard deviation squared. So if we want to find the standard deviation squared, or the sample variance, we would be able to go back to our calculator and look at our standard deviation, which is 0.7095821.857. But remember, we're using variance, and variance is squared standard deviation. So we're going to take this number and we're going to square it. So 0.709, and we're going to square it. And when we do that, we get 0.5026. So we'll say 0.503. The next thing we're going to talk about is the definition for confidence interval, margin of error, and confidence level. A confidence interval for a parameter has two parts. An interval calculated from the data, which has the form estimate plus or minus the margin of error. So when we talk about it having two parts, it's going to be the estimate plus the margin of error, and then the estimate minus the margin of error. And that's where the two parts come from. So then what is a margin of error? So a margin of error tells us how close the estimate tends to be to the unknown parameter in a repeated random sampling. Next is a confidence level, which we're going to call C, which gives the overall success rate of the method for calculating the confidence interval. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter value. So interpreting confidence levels and confidence intervals. Confidence level. So to say that we are 95% confident is shorthand for 95% of all possible samples of a given size from this population will result in an interval that captures the unknown parameter. A confidence interval means that to interpret a C% confidence interval for an unknown parameter, we say we are C% confident that the interval from blank to blank captures the actual value of whatever the population parameter is in context. So an example of this, interpreting confidence interval and confidence level, would be in late 2009, the Pew Internet and American Life Project asked a random sample of 2,253 U.S. adults, do you ever use Twitter or another service to share updates about yourself or to see updates about others? Of the sample, 19% said yes. According to Pew, the resulting 95% confidence level is, or confidence interval is, between 0.167 and 0.213. So what we need to do is interpret the confidence interval and the confidence level. So we'll start with the confidence interval. So, because we know that the confidence interval is 95%, then we would say we are, and I'm going to type this so that it's maybe a little easier for you to read. We are 95% confident that the interval from 0.167 to 0.213 contains the actual proportion, P, of U.S. adults that use Twitter or another service for updates. So next we'll talk about confidence level. So again, we're using 95%. So in 95% of all possible samples of 2,253 U.S. adults, the resulting confidence interval would capture the actual proportion or population proportion of U.S. adults who use Twitter or another service for updates. So check your understanding. How much does the fat content of brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation sigma is 2.84 to 7.55. One says interpret the confidence interval. So for number one, if we need to interpret the confidence interval, we know that we're using 95% as our confidence. So we would say we are 95% confident that the interval 2.84 to 7.55 grams captures the true standard deviation of the fat content of brand X hot dogs. Number two says interpret the confidence level. Again, using 95%. We would say in 95% of all possible samples of 10 brand X hot dogs, the resulting confidence interval would capture the true standard deviation All right, 3 says true or false. The interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation sigma. Justify your answer. So for this one, it's false. And the reason it's false is the probability is either 1. So that would be if the interval contains the true standard deviation, or it's 0. And the 0 would be for if it doesn't contain the true standard deviation. So next we're going to move on to calculating a confidence interval. So the confidence interval for estimating a population parameter has the form statistic plus or minus the critical value times the standard deviation of the statistic, where the statistic we use is the point estimator for the parameter. So again, this plus or minus means that we're going to have the statistic plus the critical value times the standard deviation. And we're also going to have the statistic minus the critical value times the standard deviation. So, conditions for constructing a confidence interval. So, the first condition is that it has to be random. So, the data comes from well-designed random sample or a randomized experiment. The second thing is it has to be normal. So, the sampling distribution of the statistic is approximately normal. And the third is it has to be independent. So, individual observations are independent. When sampling without replacement, the sample size N should be no more than 10% of the population size, capital N. The 10% condition, so you know that better as the 10% condition, to use our formula for the standard deviation of the statistic.